What's up, everybody? Hope you guys are doing well. It's Monday, and we got a little bit of magic. So if I take the number 2 pencil here, I just gotta give it just a little shake, and it's gone. Give it a slight shake. Just give it. Alright, today we're looking at 12-7b, solving nonlinear systems by graphing. The key difference here is that we will be graphing these to solve for these solutions. Friday we talked about how to find the solutions by using substitution and elimination, which is perfectly fine to do it that way, but today we're looking at another method to find the same types of solutions using our graphing calculators and graphing. If you don't have your graphing calculator, I did email everybody a link to download the TI calculators, TI-84 calculators on your laptop or desktop. If that doesn't work for you, you could always use Desmos. That's okay. So to solve for our solutions by graphing, if you recall, the main thing we're looking for are intersection points. We could have one solution, we could have no solutions, one solution, two solutions, three, or four, but the number of solutions depends on how many points of intersection you have. So in our first example here, we don't have any points of intersection, so there's no solutions. This one here, we only have one point of intersection, so we'd have one coordinate point as our solution. Here we have two solutions because there's 2 points of intersection, so we have 2 xy coordinates as our solutions. And we have 3 because we have 3 points, 1, 2, 3, and then 1, 2, 3, and 4. We have 4 solutions. So it's really key here that you have to have your solutions as xy coordinates. If you don't do that, it would be an incorrect answer. So how do I get these xy coordinates? By graphing. Well, the main idea is that we're just going to take our equations, these down here, we're just going to graph them, and then we're going to look where they cross each other. It's that simple. So our first example, solve the nonlinear system by graphing, and here is the 2 equations we have. They're in there. Now to enter this into my calculator, I have to get it into y equals whatever. Now I have these 2 equations here, so I'm going to have y1, y2 in my calculator. But before I can enter that to my calculator, I have to get into the y equals. So let's look at our top equation here. Notice I don't have it in y equals, so I have to do a little bit of algebra to solve for y. So our first one, I have 2x minus y equals 1. I'm going to subtract, if I can get this, subtract 2x from both sides. That gives me negative y is equal to 1 minus 2x. I'm going to multiply both sides by negative 1 to get y equals, I'm going to swap these around a little bit, 2x minus 1. Because what you get is y equals negative 1 plus 2x. So I just swap those two to get that. So that's my first equation. I'm going to circle it because it's important. Now let's look at my second equation. Now I need to get that as y equals. So come over here for this one. So I get y plus 7 equals 2 parentheses x plus 1 squared. All I got to do here, subtract 7 to both sides, and get y equals 2 parentheses x plus 1 squared minus 7. So those are my 2 equations that I'll put into the calculator. Now, the calculator is on my laptop, so it might be a strange cut because I got to switch to my laptop for the video. But we'll be using our calculators for the next step. Okay, so once you solve for y in both of the equations, you get to enter it into your calculator. So if you look at your calculator, here's your buttons. You're going to hit y equals. I got to clear everything out, make sure everything's cleared. So you hit y equals, that brings you up to this page, and then you enter your first equation, which we have, let's see, y is equal to 2x minus 1. My second equation is 2 parenthesis x plus 1 close parenthesis squared right here, and then minus 7. I graph it. There's my two equations. Now we have a linear function and a parabola. Now I'm looking for the intersection points. This point right here and this point right here. The intersection points of the two graphs, not the x and y axis, the two graphs. Now you could probably just look and kind of figure it out. We'll go -2 and then 1, 2, 3, 4, 5. So -2, -5. And then we have 1, 1. That's what it looks like. But on our calculator, we can actually use one of the functions to determine where the intersection points are. So if you come over here, you hit second, and you hit trace, it brings you to the calc part. Notice we have all these different functions here. I'm going to go down to the intersect part. So I'm just going to go down to 5 and hit enter. It says first curve. Notice that it's blue. On some of the calculators, the newer ones, the colored ones, you can have tell which one's which by the color. But I'm on the linear function here, so I hit enter to select the first curve, which is really, in this case, the line. Second curve is the parabola. I hit enter. Now it says guess. So to guess, I'm just going to move the cursor to where it looks like the two graphs intersect. Hit enter. And notice it gives me the XY coordinate. Now, that's my first point. Notice I do have another intersection point over here. So I'm going to do the same thing. I'm going to hit second, trace, and this time I'm just going to hit 5. Notice the 5 here, so I'm just going to push 5. Same situation. I'm going to push over. Notice I'm on the right curve. Now to swap curves, to swap functions, I can just push up and down. Notice that swaps the functions. So just hit enter. And the second one, I push enter again. I might guess. So this time I'm going to go over to my other points of intersection, close to what I think it might be, right about there. Hit enter, and it gives me a new XY coordinate, 1, 1. So that's how you find the solutions of the first problem. Now once you plug the two equations in the calculator, and you find your intersection points, you get a solution of -2, -5, and 1, 1. So that would be your answer from the given graph. All right, let's go ahead and look at this question here. Now I could use elimination, I could use substitution if I wanted to solve for this one. But let's use our graphing calculators to look for those intersection points. So I have my two equations. I'm going to start with my top one. Again, I want to get into y equals something. That's my goal. So I have x squared plus y squared equals 25. I want to solve for y, so I'm going to subtract x squared from both sides. That gives me y squared is equal to 25 minus x squared. Now I have to square root both sides. So that'll give me y is equal to, now it's important to have plus or minus, the square root of 25 minus x squared. No, it's 25 minus x squared, so that's grouped together. So you can't do the 5 minus x because throw things off because PEMDAS applies. So I have this plus minus here. So my 2 y1 is equal to the square root of 25 minus x squared. And then y2 is going to be negative 25. Let me erase this. Let's make it more apparent. Negative root 25 minus x squared. Those are my first two equations. Now let's look at this one here, that over here. This one's a lot easier. Y minus 5 equals negative x squared. All I got to do is subtract, add 5 to both sides. So add 5, add 5. That gives me negative x squared plus 5. So this will be my third equation that I have to enter. Right there. So I have these three equations that I need to plug into my calculator. I'm going to plug it into my calculator. I'll just check for the intersection points. Now for my second one, what you're going to do is, after you find all three equations you need to enter, well, first thing I'm going to do is hit second square root. I'm just going to use parentheses just because it's a good habit. I'm going to do 25 minus, where's my x squared, close parenthesis. Go to my second function, and don't use the subtraction sign here. Make sure you use the minus sign. So negative square root of 25 minus x squared, close parenthesis. I'm going to go to my third function, negative, don't use a minus sign, use negative x squared plus 5, and I hit graph. Now I'm just going to hit zoom, and then 5, I'm going to square everything off, and notice that we have a circle and a parabola. The original one looked more like an ellipse because both axes were different. The units were slightly different. So you just hit zoom 5 and it squares everything off so you can tell what kind of shapes you have. So I have a circle, and then I have my parabola here. So it looks like I have an intersection point here, right here, and right here. So I hit second, trace 5. Now it's going to be really important to make sure you know which function you're working with. So notice I'm on the top half of the circle. I hit enter. Right now I'm on the bottom half of the circle. I'm going to swap to the other equation. I push enter where it looks like the first point of intersection is, and that's 0, 5. Now I'm going to do the same process, so I took care of my top intersection point. So hit enter. Actually, let me redo that because I already took care of the first one. I'm going to jump to the second function, the bottom half of the circle. So I'm on the bottom half of the circle. I hit enter. I'm on the parabola. So I hit enter. I have to guess for the point of intersection. Right about there. I get 3, negative 4. So I have one more point of intersection. Hit second, trace 5. Jump to the bottom half of the curve. Enter. I'm on the parabola. Just pushing over to the left. Hit enter, and then guess right about there. Negative 3, negative 4. So that's how I get all three intersection points. Again, it's kind of easy to tell just by counting, but if you had decimals or something, using that intersection function is pretty helpful. So my solution that I get here is 0, 5, and then I get plus or minus 3, negative 4. So that would be my answer. Alright, so remember you guys do have a test this week on chapter 12. I'll be letting you guys know what the schedule will be like for if you guys need extra help one-on-one. Wednesday we're going to have a little bit of review time. That's all we're doing Wednesday, just reviewing. Tomorrow we're just going to have more review. I'll probably have another video of different questions I want you guys to look over and how to do them. But if you need any help, shoot me an email and we'll get in contact. Alright, see ya.